All right, today we are going to be moving into our optical devices, mirrors. Yesterday, or the last lesson, was focused primarily on the definitions, like the primary axis. Did we get to, I'm just double checking, did we complete virtual images? I believe we did.
Yeah.
Okay, cool. Then, so I am recording this, and those of you who are listening, we are using a series of mirrors in class to help with understanding what we're going to see and literally seeing what's being talked about. So I realize you may not have you're not going to have all of these nice mirrors at home when you're watching this, but you can recreate a lot of this using um, a spoon that you can see your reflection in, and like a bathroom mirror. So if you're looking to, and so if you're trying to remember what everything was, those devices help a lot, can help a lot even when you're at home, to make sense out of things. So the first optical device we're going to start with is a mirror. And the first, and we're going to identify the mirror by shape to start. So the first shape we're going to start with is a planar mirror. A planar mirror in general will be represented on the primary axis as literally a straight line, vertical line. Okay. You have planar mirrors in front of you here, but they're slightly tilted. Yes. Okay. So they can stand. At home, the planar mirror is usually pretty flat. Okay. Um, one of the, and One of the things that you will notice about a planar mirror, and you can play with this right now, and I'm going to give you a chance to do this, is that they can produce only virtual images, literally only right side up. Okay. Virtual images, remember, are the ones that are right side up, and the light isn't actually going there. This is that idea of if you're looking in the planar mirror, okay, do you see mirror you? Okay, you can wave at mirror you. Yeah, okay. And where does mirror you appear to be? Behind the mirror. Doesn't it look like it's behind the mirror? Now, reach out closer to the mirror. Okay. Put your hand up. Is the image of your hand still virtual? Awesome. I'm going to have you do a silly kind of experiment, but can you get up in the aisles? Okay. Turn the mirror so that it's like facing out, and I'm going to have you back away in the aisle until you're no longer virtual. So you may have to, like, you may have to move your chairs. You may have to, where you can't, where you no longer, where the image is no longer virtual. Virtual meaning right side up. You have to be upside down.
Yeah, like the ceiling.
Like the ceiling is below you. Does that happen? Okay. Put your hand above your head. Does your hand appear to be above your head in the image? Yes. Okay, fine. Then it still hasn't turned virtual. Does that make sense? Yeah. Okay. The ceiling would have to be at the bottom. Is there a point that you can be far enough away from it and have it be virtual? No. Planar mirrors it's always going to be virtual. You can never get a real image with a planar mirror. Okay. And it has what we call an infinite focal length. And in that, like, what the heck does that even mean? The focal length is the distance to the focal point. The focal point is where all the light either actually focuses or appears to focus, right? So if it appears to we'll get to some other ones there, but basically, how far away from the object do you have to be in order for the light from the object to appear as if it's just a teeny tiny point? Infinitely far. Does that make sense? Like, objects still have height in the mirror until you're an unbelievably huge distance away. Yes.
So it's like in order to make it not virtual, you have to be infinitely away to be like, or
To make it look like the light is coming from a single point as opposed to a larger object.
okay.
Does that make sense? Like all the light gets focused to a single point. The only place you would see it as if it was a teeny tiny point is if you're infinitely far away. Okay. Your example of a planar mirror is a bathroom mirror. Okay. Now, with a planar mirror, one thing that you can say, and I know you've seen this, is that, like, if you were to draw an object, for me, I stink at drawing. Is that a fair assessment? Would that be a fair an agreement? Okay. Now, I'm going to right now, I'm just kind of putting my hand near here. I'm going to draw my object as a arrow. If this is my object, what would the reflection look like?
Like the object is behind the mirror.
Behind it, would it look like this?
It would be pointing towards the object.
Oh, it's pointing towards the object? Yeah. Absolutely. It would look like it's the object just, and the points that are closer to the mirror are going to appear closer behind the mirror in that image. Does everyone agree with that?
Mm-hmm.
Can we also agree that that's something you kind of understand from the fact that you have used mirrors before? Okay, all right. Now, here's a question. Have you ever seen a dog or a cat look in a mirror?
Potentially. It's not, yes.
Maybe? Okay. Is this something that we might need to go look at on YouTube?
Potentially.
Okay, all right. So we're going to pause this and go search for stuff on YouTube. Please feel free if you're watching this to, take a YouTube break on this one. Hold on. Trying to pause it, but I don't think it's going to pause because, oh, wait. Okay, so we should be back to sharing our screen, and I'm going to attempt to get this back to this one. Yeah, no, I need to stop duplicating. Sorry about this, everybody, but the joy of okay, we need to take this one. Let me get out of it and put it back into. There we go. Okay, so now we're back to the right set of video diagrams and stuff like this that we want to use. So at this point, at home, you want to grab your spoon, or here you want to grab the mirror that I handed out. Okay, and the next one we're going to look at is concave, which means, do you guys see that that the mirrors, that your spoon basically has two sides to it? You have the soup side, yes, and the side that you don't eat with. Do you guys know what I'm talking about?
Yes.
Okay. The side you eat with, the part that's caved in, is called the concave side. So I want you to look at the concave side, the side that is curved in, not curved out. Okay. Do you guys see which one is which? Can you tell which one is which? Yeah, okay. So the concave one, and by the way, in all of these situations, the way you need to think about this is that the object, and we're always going to use this, is that the object, come on, or light source is coming from the right-hand side. Okay. Or sorry, that's left-hand side. I cannot. Okay. So right now, okay, with your concave mirror, we're going to find that they can produce both real and virtual images. So do me a favor, hold the concave mirror super far away from you. How do you appear in the mirror? Okay, now tilt it to the side to like look behind you. Does the stuff look upside down?
Yeah.
Like tilt it to the side so that you're looking behind you. So this would be the eating side of the spoon. Okay. Look behind. Does the stuff appear upside down? I think you have the wrong side. You're confused.
I am a little bit confused.
You are not using the right side.
Okay.
That's why I was like, I think you're using the wrong side because I could see it was upside down, so you're holding it this way.
Oh, facts.
Okay, so look behind. Can you like look into, or like look into the part of the room that you can more easily see?
Ah, the light fixtures.
Izzy, stop moving. I had you upside down.
Oh, sorry.
Where'd you go?
Okay.
Gotcha.
I see your eyeball opening.
All right. So that upside down image. Yes. That upside down image is a real image. The light is actually coming together at that location. Okay? Do me a favor. Where does that real image appear to be in it? Does it look like it's behind the mirror, or does it look like it's floating just a little bit in front of the mirror?
It kind of looks floating. Maybe that's my eyesight.
Nope, that's exactly what it should be.
Okay.
Real images appear on the same side as the object. They're going to appear to float in front of the mirror just that teeny tiny little bit. That was the thing yesterday with the witch eraser.
Yeah.
So if you don't look direct, like do you see like an eraser?
Yeah, kind of.
Okay, go ahead, try to poke, like don't look straight into it, but just from where you're sitting,
Wait,
move
no,
your
it's
finger.
like up. Isn't it right here? Oh my god, it's not right there.
Yeah.
Oh my
Real
God.
images float in front of the mirror, which looks a little bit odd to you because you're used to your bathroom mirror where the images all appear behind it. Okay? Now, I want you to take your spoon or your concave mirror so that it is, remember, that's the side that's like the spoony side of it, and slowly move it towards you until you get a virtual image.
Oh my god, my eyeballs look kind of cool. I can see all my pores.
What happens in this situation?
It is extremely magnified.
Okay, it's magnified. It's getting larger. Yes?
Yes.
Okay. In the planar mirror, planar mirrors are zero magnification. Planar mirrors, if you put your hand like up to it, your hand in the mirror is the same size as your hand in general. If you put your pinky in front of the concave mirror, kind of close to it, does it look like your pinky's huge? Come back a little bit then.
Oh yeah, no, it does.
Yeah. And the exact amount of magnification and everything depends very much on exactly where it's located. Okay. Concave mirrors actually focus light, and the light focuses at what we call the focal point F. Therefore, it has a positive focal length. This you might want to write down. Sorry. All right, so I'm going to put this on duplicate for a second. And we are going to watch this. What we have here is a concave mirror, okay? And this is going to be a situation where they use the concave mirror to focus the light. And what do we mean by that? and you're going to be able to see the light or the area being focused because they're using full spectrum light, which would include heat and IR, and the heat from the IR, you can start actually to see they're going to spray water at it basically, and the water droplets will be attracted to and kind of show you exactly where the light is focusing and then like spreading out again. So let's watch this.
How tight does this focus? Can we see it?
Just look, yes. By spraying some water.
Oh my God. So if my hand's here, it's okay, but if it went there, what would happen?
Not at the focus. Here it's okay, but...
And even a mirror this big, would it be powerful enough to kind of set light to something?
Yes.
Can I try it?
Go ahead.
Okay, show me the focus. I'm okay. Oh, my life. Can we do that again? That's astonishing. I've never seen anything set light to wood that quickly. How hot is it in there? What temperature does it get to?
At that focal point, we can reach a temperature higher than 3,500 degrees C, and there is currently no known materials that could resist this.
There is nothing on Earth that can withstand the temperature right in the middle there.
Nothing.
And I'm pointing at it.
Exactly.
Just 2 square meters of sunshine can melt steel pretty easily. I would love to try and weld some stuff with sunshine. It'd be really nice. If you had 3 people sunbathing, they would be collecting that amount of sunshine. And look what it does.
If you concentrate it.
Despite having traveled 93 million miles, the energy of the sun can even melt rock. Look at that. See, to me, that's far more amazing than melting steel. Like, I see steel melt every other day, but I've never seen anything like that.
Okay. I love that video. Like, that one is one of my absolute favorites. And I kind of feel like this is a really cool, oh my goodness moment. Agreed? Okay. Now, getting back here. Let's get back to, nope. And nope, I need to get out of the slideshow again. Sorry about this, everybody. It just doesn't like me. All right, we're back. Okay, so the example we would have for a concave mirror would be what you would describe as a makeup mirror. Makeup mirrors are the ones that you want to magnify. So like if you're attempting to put mascara on, that you can see your eyelashes. As someone who has predominantly blonde eyelashes, it's very helpful to be able to see them. Or it looks like I'm drawing eyeliner on when I put mascara on half the time. Because I miss my eyelashes because they're hard to see. So I just put it on my skin. It's not a good look. Okay. Yeah, but still not usually the look I'm going for. Okay. Now, if you go ahead and flip around your spoon so you're on the side that you don't eat off of, or you make it convex, okay? Convex is that bowing out, okay? In a convex situation, okay, look behind it. Okay, look at yourself, okay? Come in. What does it look like?
I look very round.
Okay, do you look? What did you say? Point.
That's what it's called. Like on my iPhone, when you put it in 0.5, it's like the wide angle camera. It's like the fisheye camera.
Okay, I was trying to say, did you say 0.5?
Yeah. Okay,
absolutely. What you're looking at there, okay, in convex, okay, now do me a favor. Remember how with concave, we like angled it at something behind us, trying to see if we could get a real image? Angle it at something behind you. Okay. Do you see what do the images look like?
virtual.
They're all virtual, yes?
Yes.
Okay. That's because a convex mirror can produce only virtual images. Okay. And before you put it down and start writing, okay, do me a favor, pinky test. Bring your pinky in front of it. How does it looks smaller? Doesn't it look? I mean, it looks. If you put it up relatively close to it versus the planar mirror, doesn't it look smaller? Okay. Convex mirrors produce not only virtual images, but images that are smaller than the object. Okay. So now you can go ahead and write. Okay. They can produce only virtual images. And those virtual images appear to be, do they appear to float in front of, or do they appear behind or inside the mirror? Behind, inside the mirror. Okay. And the light appears as if it's focusing at the virtual focal point. But what's really happening is the light is spreading out. Okay. So if you want to include this in your, and this is just a very bad version of this, is that a fair way to say it? Okay. So if you have light coming in, and I'll draw this in now, and then I'm going to end up stopping this for a second. Or at the end, I'll stop this a little bit early, and we're going to use the laser box to play with it, okay? But the idea is with the laser box, remember we had light coming in parallel? Okay. With a concave mirror, the light will follow the laws of reflection and bounce off and actually focus at the focal point. Whereas with a convex mirror, sorry, I'm getting the light to come in, and then it doesn't actually come together, but rather bounces off in such a way that it's like your eye extends it backwards to what we call the virtual focal point. You are going to see me meticulously every time that light appears to go somewhere where light can't go, always dash those lines. Because light isn't going there, but our eye and a camera, a lens, anything is basically interprets the light as having come from a location where light can't actually be. Does that kind of make, so that's where you would see the image, it's just behind the mirror versus floating in front of the mirror. Does that help with the idea of what's happening? Okay. And an example of a convex mirror would include like your rear view mirrors. Your rear view mirror is not perfectly flat. It is slightly convex. Then they are absolutely your side view mirrors and your rear view mirrors. They're designed to be slightly convex in order to give you a better, fuller view of everything from side to side. Okay. Are we ready? So we're going to get to the definitions of converging and diverging. Okay. Converging means it is an optical device that actually focuses light. The light actually comes together at the focal point. So which type of mirror did we set? Which shape of mirror did we have that converged or brought the light actually together? Concave. Absolutely. If converging is bringing it together, what do you think diverging means? Spreading it apart. Absolutely. It's the optical device that appears to focus the light at the virtual focal point. What it actually is doing with the light is spreading it out. You're absolutely correct. 100%. So which shape mirror spread the light out? Convex, absolutely, 100%. Okay. Next class period, we are going to be working on drawing ray diagrams, drawing pictures that help us understand how the light moves in order to see everything. I will tell you right now, I have an animated PowerPoint for this. That animated PowerPoint is, in my opinion, the most helpful thing I think I have ever created in my career to help students practice doing this. As long as you are in, I'm like, downloading it as a PDF or printing out the slides is utterly useless. You want it in presentation mode. You want it to be animated so that like you click and you draw the line that you're supposed to draw. And so you can check, you can be like, okay, now I think it has to go this way. And then you can hit enter and check, oh yeah, that's the way it goes. And you can draw it in with confidence. And it can be your like best friend while you're doing your homework or working on it in class. You can just have it there to help you as you're first getting used to it. Okay. But I'm like, yes, you can print out the final product. But my argument is with drawing these diagrams, the final product doesn't tell you what to draw when. Okay, so that's what we want to do. All right, so I am going to stop recording and we're going to use the mirrors and lenses using the laser ray box to mess with this a little bit here and now.